right, so this is a little bit more about fractions. We've got some definitions here. So an improper fraction is one with a bigger than b. Okay, so we have a fraction where the top is bigger than the bottom. We call this an improper fraction. So a proper fraction a over b is one with a less than b. So maybe say 5/6. All right. And you may ask, what about if a equals b? Well, if a equals b, that would be like 2 over 2 or 7 over 7. That's just equivalent form to 1, right? So we don't do that as an example. And then we say a mixed number is one with a whole number and a fraction. So 2 1/3, 11, and say 5/6. And typically, right, this part is proper. The fraction is proper on that. All right. So one thing that we do is we can change an improper fraction into a mixed number and vice versa. So let's talk about that. Right, 2 1/3 as an improper fraction. And we're going to do using an area model, first of all. I'm going to go ahead and do circles. It doesn't really matter, but got that. So 2 1/3, right? It is 2 wholes and then 1 out of 3 pieces on the third one, right? And what we really want to do is we want to figure out how is it that we get how many total fractions are there. And this is fairly straightforward. I'm going to cut these guys into thirds and then leave that one in. And then basically we're just counting. So this shows 7, 1, 2, 3, 4, 5, 7 thirds, right? Okay. Now, you can also see basically what this does is how did I get this? Well, a whole, right, if I'm cutting into thirds, is 3 thirds. There's another 3 thirds. And I have 2 wholes from that, right? Or 2 times 3, as we're doing the 3 comes from the denominator on that, plus on thirds, right? So there's my 2 plus 3 thirds, and there's my 1/3, and that's just 7 thirds. Okay, because if I want to do, right, so write, let's say 11 5/6 as a improper fraction. It's just 6 times 11 plus 5 over 6. 66 plus 5 over, so 71/6. So fairly straightforward, I think, on that. Well, how do we go the other way? Right? So let's do the opposite. So let's write 17/5 as a mixed number. Okay, well, one thing that we can do with this is I'm going to do a model first. So, and I'm going to do fifths. I'm going to use squares instead. Fifths are always hard to draw on circles. Let's see. So there's 5. There's 10. There's 15. And then there's 17. Okay. So I have 1, 2, 3. So this shows 3 and 2/5. Good. All right. Now, this also kind of shows a different way of thinking about it. Okay, what am I doing here is I'm taking 17 and grouping it into size 5, right? So this is really just a division problem, and I'm thinking about 5 as how large they are. So this is a measurement division problem that we're just going to do, right? So 17 divided by 5, which is 3 remainder 2. So 17/5 can be written as 3 and 2/5. There's the 3, there's the 2, so 2/5. Right, so we can also do something even bigger, so write, let's say 302, say 17ths as a mixed number. $13, 132. Let's see, how many is that going to be? 5 is about 87. It might be 8. I'm going to try 8. 56. 8 times 1 plus. Oh, it's too big. Okay. So it looks like it's going to be 17, 7, 7, 49, 11, 3, 1. Right? So then this is going to be what? 17 and 13/17. So I didn't mean that to be the same, so hopefully that's not confusing, but we've got that. Okay, so this shows a lot about improper fractions, mixed numbers, and how they're all related.